Okay, here we go. This is a TREX 600 Pro DFC build. Here we have all the parts laid out on the counter, ready to go. Quite a few pieces. Canopy sure is pretty, isn't it? It's got the Castle HV80 speed controller. For this particular build, we're going to use the 700 F3C landing gear, which will get the helicopter a little bit farther off the ground. I like to start with gluing the end caps on the landing skid pipes and the canopy nuts so that it's nice and dry by the time we get around to using these parts. Align wants to make sure that they have enough screws for all the parts they've included, so they install the screws in all the parts. So now we have to remove them all. I start by putting all the mounts on the servos, including the brass inserts. Make sure that you use Loctite on all metal connecting parts. I like to start by installing all the servos in each frame section so that when it comes to assembling the frame, the servos are already in it. As you start to install the bearing blocks, make sure that you drop the main shaft down the bearing blocks so everything is aligned when you tighten it up. When you set the motor in place with the frame half put together, you can adjust the pinion height to the lower thrust bearing so that it has the proper clearance. It's easier to put the front canopy mounts on now before the frames are assembled. That way you can get to the inner screw. I like to put the zip ties in place before I put the frame sections together. That way it makes them easier to get in. Now it's time to assemble both frame halves. Notice that the main shaft is in place to keep everything aligned when you tighten it up. Depending on where you mount your ESC, it will make a difference in which direction you have the motor wires facing. On this particular build, I'm going to put the ESC up front so the motor wires are facing forward. Installing the elevator mechanism can be a little tricky because it's not much working space. Make sure that you get the end play taken out of it so there's no slop in that arm system. When mounting the nose cone, make sure that you run the motor wires through the holes where you're going to mount the ESC. Each servo wire, you can use an X-Acto knife to reach in there and lift the tabs and pull the wires out. After you install the wrap for each wire, make sure you get the wires back in the connectors going the right direction. Now it's time to solder all the motor bullet connectors on the ESC and the power connector at the end, depending on what type of batteries you use. On this build, we're using a T connector. I've mounted the ESC nice and snug inside the nose cone. Now you can route all the wires nice and clean and tie them up. When you get all your wires routed, you should have a nice clean look. I chose to mount the voltage regulator on the opposite side of the ESC in a direction where the switch is up for on and down for off. In this picture it's a little hard to tell, but I used a Dremel tool and I widened the opening just in front of the front canopy mount, and if you look across the frame section you could see that it's much larger than the one on the other side. This was done so that when you put your batteries in there, your power wires won't accidentally get cut on the carbon fiber. On this build, we're going to be using the Align serial connector. As you can see, this has turned out to be quite a clean build. My next step is to work on the tail assembly. This is where I like to spend a lot of attention, because a sticking tail will have adverse effects on the flybarless unit and make the helicopter tough to fly. The first thing I do is take the tail assembly completely apart. I swapped all the gears out for the new Delrin black gears, and I use Loctite to put everything back together. You want to pay close attention when putting together the pitch slide assembly that you do not get Loctite in the brass collars. Now we've changed out the front umbrella gears in the front housing with the new Delrin black gears as well. At this point, we put the front housing in, the main and auto gear, and get everything lined up. For this build, I'm going to use two torque tube bearings. Rather than super glue the sleeve onto the carbon fiber shaft, I choose to put a piece of heat shrink around the stainless steel slide so that it slides smoothly on the carbon fiber shaft. Install the ball links on the carbon control rod and assemble the tail housing onto the tail boom. Now it's time to set all the servo neutral points and adjust all the servo arms so we have a flat swash for setup. Now it's time to install the landing gear. I do this later because it makes it easier to work with the helicopter with the bottom plate off and the landing gear off. So now it's time to assemble the head. Please make sure that you've taken the head completely apart and put it back together with the correct lube and Loctite. Now it's time to install the tail boom, braces, and control rod. Don't forget the little piece of Scotch tape under the boom clamps to keep it from twisting. Now we can install the tail blades and get ready for setup. The first thing we're going to do is we're going to program the ESC. For this build, we're going to use the governor mode. We selected what type of helicopter it is, or what type of vehicle it is, and the throttle type. Initial spool up rate, we're going to use medium, and for the governor gain, we're going to use medium. Down at the bottom, we have to pick the battery pack voltage, and then we pick the head speeds we're on. You can see that we're using an auto LiPo cutoff voltage, and when it drops down to 3.2 volts per cell, that's when it's active. Now that we've programmed the ESC, it's time to check the 3GX unit to make sure that it's running the most current software. After we've done that, we're going to check the blades for balance and balance them if needed. I particularly like the RC Logger digital pitch gauge. So now it's time to go through the setup on the 3GX unit. While holding the set button down on the 3GX unit, you power it on, and this puts you in DIR mode, which runs you through all the setup parameters. While you're in DIR mode, you can set the tail center. Now you want to set 0 pitch at mid-stick. After you've set 0 pitch, it's time to set your total collective pitch and your aileron pitch. After you've set your aileron to 8 degrees, match the elevator setting in the swash list to match your aileron. Now it's time to calibrate your throttle. You can watch the Castle Creation throttle calibration on YouTube to see how to do it. Now it's time to test fly your helicopter. We have several test flights on it, setting the gain, and everything works as it should be.